Hello, myself Rutvik Sonone. So, for subject machine learning and application, my topic is machine learning in self-driving cars. So, what is machine learning? Machine learning is a method of data analysis that automates analytical model building. So, it is a branch of artificial intelligence based on the idea that system can learn from data, identify patterns, and make decisions with minimal human intervention. So, uh, self-driving cars means what is meant by self-driving cars? So the cars or trucks in which human drivers are never required to take control to safely operate the vehicle means there is no driver. So it is also known as autonomous or driverless cars. That they will combine with sensors and software to control, navigate, and drive the vehicle. So how self-driving cars works? So the how exactly it works? So the driverless car can identify objects, interpret situations, and make decisions based on object detections and object classification algorithm. So they do this by detecting object classifying them and interpreting what they are. Actually, it is. So the next diversity and redundancy. So in that machine learning is a accomplished through a fusion of many algorithms that overlap to minimize failure and ensure safety. These algorithms interpret road signs and identify lanes and recognize crossroads. So the next that how does self-driving cars are seen? Means how can he see the objects or cars? So let's see. There are three major sensors used by self-driving cars to work together as human eye and brain. These sensors are cameras, radar, and lidar. Together, they give the car a clear view of its environment. They help the car to identify the locations, speed, and 3D shapes of objects that are close to it. Additionally, self-driving cars are now being built with inertial measurements units that monitor and control both acceleration and location. Okay, so uh, that we have seen that three major sensors, that is cameras, radar, and lidars. So that is the first one, reliable cameras. uh, there are in self-driving cars have a number of cameras at every angle for the perfect view of their surroundings. Which comes camera have a broader field of view of about 120 degrees. Also the radar detectors. So the radar detectors augment effort of camera sensors at night whenever visibility is poor. Next, laser focus. It is also used to calculate distance through pulse lasers by empowering driverless cars with 3D visuals of their surroundings. And the next one, lidar. It is the one of the most important technology used in development of self-driving car vehicles. It is here lidar and laser focus. So the algorithms used uh, in machine learning there are two types, means supervised learning and unsupervised learning. In supervised, group and interpret data and based only on input data, means in supervised learning input data is required, or in unsupervised learning to develop predictive model based or both input or output data. Okay, means in unsupervised learning there are means predictive based all. So in supervised there are two types, classification and regressions, and unsupervised there is only clustering. So the next one, machine learning algorithms used by self-driving cars. Means which machine learning algorithms are used in self-driving cars. So the first one is SIFT, that is a scale invariant feature transform for future extraction. It detects object and interpret images. So you can see, for example, means for a triangular sign, the 3 points of the given are entered as features. A car can then easily identify the sign using those points. You can see here. Okay, here you can see. So the next one, Ada Boost for data classification. Here is image. For in that, these algorithms collect data and classifies it to boost the learning process and performance of vehicles. It groups different low performing classifiers to get a single high performing classifier for a better decision making. The next is text on boost for object recognition. Here you can see the input image, then text on map, and in the third image feature pair on in the fourth super most rectangles. So the text on boost algorithms does a similar job to other boost, that is only it receives data from shape, contexts, and appearance to increase learning with textons, that is microstructure in images. It aggregates visual data with common features. So the next one is histogram of oriented gradient, that is also called as HOG. Here you can see the input image, gradient image, and the next one is orientation voting plus local normalization. Here you can see in that means HOG facilitates the analysis of an object's locations called a cell to find out how the object changes or moves. It is a one is a more interesting, that is a uh, it means find out how the object changes or moves. Here you can see in that HOG. So the next one is YOLO. YOLO, full form, you only look once. In these algorithms, here you can see there are three images. Okay, and the next one is you can see here that the uh, rectangle are around the images, and the third one is it have detected the what actually it is. So it's most interesting in this most interesting algorithm. So in this YOLO, you can see here. So in this YOLO, this algorithm detects and groups objects like humans, trees, and vehicles. It assigns a specific feature to each class of object that it grouped to help the car easily identify them. And the YOLO is the best for identifying and grouping objects. So it is the most important in self-driving cars. So finally, conclusion. In that we have seen that machine learning algorithm make it possible to self-driving cars to exit. They allow car to collect data on its surroundings from cameras and other sensors, interpret it and decide what actions to take. So the machine learning even allows cars to learn how to perform these tasks as good as humans. This leads to the reasonable conclusion that machine learning algorithm and autonomous vehicles are the future of transportation. Okay, thank you.